Hello there. In this lesson, we're going to learn about polyatomic ions. So poly means many, means more than one atom. And of course, these are ions, which means they are charged. And so you might have seen some clues as to their existence already. You've seen lots and lots of compounds that end in IDE. And IDE means it's a binary compound, and that means two elements. And so anything that doesn't have the IDE ending, this is an AT ending, and there are other variations. This is going to be more than two elements in these type of compounds. So we're going to see how that's possible throughout this lesson. So another way of looking at a polyatomic ion is to think of it as a molecule, but with a charge. And so the molecules we made in the last lesson all had equal number of protons and electrons. So here's an example. This is carbon dioxide, right? And it has 6 protons here and 8 protons here and 8 protons here. And if you add up all the electrons, it should be the same number. So 8 and 8 is 16 plus another 6 makes 22. And if you add up the electrons, you also get 22. And so overall the charge is 0. And so this is just your ordinary molecule. But if you do the same thing with this molecule, you end up with 8 and 8 makes 16, another 8 makes 24, and another 6 makes 30 total protons, 30 positives. And then if you do the same thing for the electrons in this molecule, you'll see that there are 32 electrons, which means overall this has 2 more electrons than it does protons, which means it has a -2 charge. So this is not only a molecule, it's a molecule with a charge, and so this is what we call a polyatomic ion, because it has a charge. And so polyatomic ions can combine with each other in the same way that any other ion does. So here's an example. This one is called carbonate with the -2 charge. And so you have CO3, which is the carbonate with the -2 charge. We got calcium, which is your regular ion with the +2 charge. And if we do our crisscross and then reduce, calcium carbonate is what you end up with. You see, it's not an IDE anymore because it's got calcium, carbon, and oxygen. And so that's 3, more than 2. Don't use the IDE ending. All right, so our first group of polyatomic ions we're going to look at are the ones with nitrogen. We've got nitrate and we've got nitrite. They are very similar to each other. You might have seen them if you look on the packaging for preserved meats. It's often used as a preservative. And so our first one here, nitrate, is a nitrogen with 3 oxygens, and it has a charge of -1. And our second one here is nitrogen with 2 oxygens, and it has a charge of -1 as well. So this one is nitrate with more oxygens, and this one is nitrite with 1 less. So to make the compound, you just list the names of the 2 together. So this would be sodium nitrate. This next one here is potassium, but nitrite, so that's going to be a K with a plus charge, and O2 with a minus charge. And since they're both +1, -1, we only need one of each. So K and O2 would be potassium nitrite. Over here we got NO3, so that's nitrate again. So this would be magnesium nitrate. And again, here we've got nitrite, and this is iron 3, so we got Fe3+, and nitrate is NO2 with a -1 charge. And what you're going to do then is crisscross those guys. Now, this is where sometimes students get a little mixed up. So you see there's this 2 down here, that's the number of oxygens. You don't want to crisscross that. It's always the number with the charge, so the 3 there and the invisible 1 here. So when you cross those, make sure you keep the 2 where it is. And if you need more than one of them, you're going to have to use one of these brackets, right? So this is going to be Fe, and it's going to give the 3 to the NO2, right? So there has to be 3 NO2s. So you put a bracket, put your NO2 in the bracket, and then outside the bracket you put a 3. So that means 1 iron for every 3 nitrites. Great. Our next polyatomic ion are the sulfates. You might have seen sulfates if you've ever looked at a jar or a bottle of bath salts. It's magnesium sulfate there. And sulfate has a formula of SO4, and it has a -2 charge. So you can use that for your compounds. So this guy here is the one that we have in the picture, which is magnesium sulfate. Potassium sulfate has a charge of +1, and sulfate has a charge of -2. So when you do your crisscross here, you end up with K2SO4. This one here is good old lead. Now, this is where a little deduction has to take place. We know that one sulfate has a charge of -2. Two sulfates, that's going to be two of them. And so overall, this is going to be a charge of -4, which means that this lead here, in order for this to be neutral and have no charge, it has to be the +4 version of the lead. So you would say lead, and then 4, and then sulfate. And this last one here, we got iron 3 sulfate. I'm going to take a little crisscrossing. I'll put it below here. Iron with the 3+ charge, sulfate with the 2- charge, crisscross, end up with Fe2 bracket SO4 bracket 3. Those brackets are important. So phosphates are neat little molecules that are found in biological settings like DNA. They are also found in foods. This is a package of bacon, and you can see it's got the nitrates, but it also has phosphates in there, help as a preservative. Fertilizers, of course, lots of plants like phosphorus in the form of phosphates. Cleaners around your house as well. And the formula for this one is PO4 with a -3 charge. This is the biggest charge we've had so far. And so this first one here, you get the K and the PO4. This is going to be potassium phosphate. There we go. Magnesium phosphate, you're going to have a bit of a jumble here. You're going to have magnesium with the 2 charge and the phosphate with the 3 charge, right? So again, make sure you don't mix up the number of oxygens with the charge, right? So it's only the charges that get crossed, so crisscross. You're going to end up with magnesium, 3 of those, and phosphate, 2 of those, and you're set. This one here, the charge on the tin here is number 2, so it's going to be tin 2 phosphate. And this last one, we get iron 3 with the phosphate, so that's Fe3+. Phosphate's PO4, which is 3-. So these guys are going to cancel each other out, and you're going to end up with just FePO4. No need for brackets. Our next group are carbonates. We alluded to this one earlier. Carbonates are found in minerals like limestone, chalk, and marble, and that's because they're made in sea creatures. They're seashells, and over a long period of time, those seashells accumulate and end up forming that type of sedimentary rock. The same mineral, calcium carbonate, is found in eggshells. And so, yeah, our first one is carbonate, which has a -2 charge. Now, bicarbonate is very similar. It has a hydrogen, though, as well. So HCO3, and it only has a -1 charge. That hydrogen balances out one of those charges. So that's our biggest one yet. It's got 3 different atoms in the polyatomic ion. All right, so let's have a look at our examples here. We got magnesium, and we got carbonate with the hydrogen. So that's magnesium bicarbonate. Next one, potassium carbonate. So K plus CO3, 2-, crisscross. You're going to end up with K2CO3. Here's nickel with carbonate, only one of them. So the charge in the carbonate is a -2, which means that nickel has to be +2. So nickel 2 carbonate. And here we have tin 4 bicarbonate. So the charge on the tin is +4. Bicarbonate is HCO3 with a -1, which means it's going to be SN. Of course, a big bracket here, HCO3, and we're going to need 4 of those. There you go. Our next group are the chlorates. Chlorates are with chlorine. and oxygen with 3 of them. You'll notice that most of these polyatomic ions we're going to look at today are bonded with oxygen. There's an exception coming up. Chlorates are used in making paper. You might notice that most paper is a nice white color. That's not how it comes out of the tree, and so in order to bleach the paper, use chlorine compounds like chlorates. They're also found in herbicides and cosmetics and things that go boom. It's also used in purifying water. It kills bacteria really well, and so there's a little bit of it left in our drinking water from that process, so you might drink it a little bit. So making these compounds pretty straightforward. This is going to be a magnesium with a chlorate, so pretty straightforward. Magnesium chlorate, don't forget the H. Potassium chlorate, you're only going to need one of them, KClO3. Nickel with a chlorate, you can see the charge of the chlorate here is -1, and there's 3 of them, so that means that this nickel has to have a charge of 3, so it's going to be nickel, 1, 2, 3, chlorate. And the last one here, we got lead 4 chlorate. Lead is going to have a charge of 4. The chlorate, it has a charge of 1. And when you do your crisscross, you're going to end up with Pb and a big bracket, ClO3 and a 4. Alrighty, next. So we're almost done. Hydroxides are our next ion. Hydroxides are just an oxygen and a hydrogen with a charge of -1. All of your strong bases are found in things like cleaners, are made with hydroxides. If you look at the ingredients in a can of Drano crystals, you'll see that sodium hydroxide is a big part of that. It's also used in making soaps. Lye is sodium hydroxide as well. That's used to mix with fats and do a chemical reaction that produces soaps. So let's do a few names. Of course, this is good old magnesium again, this time with hydroxide. Potassium hydroxide, since both of these have the same charge, it'll just be 1K and 1 OH. Nickel, this time with 3 hydroxides, so that means it's got to be the nickel with the 3 charge, hydroxide. And the last one here, lead 4 hydroxide. Again, hydroxide has a -1 charge. The lead has a +4 charge. And so you're going to end up with Pb bracket OH bracket 4. There we go. Alrighty, our last ion is called ammonium. It has the formula of NH4 and a charge of +1. So it's unique for 2 reasons. Number 1, there's no oxygen. And number 2, it has a positive charge rather than a negative charge. So this is to illustrate that you can have positively charged polyatomic ions. This is the only one we're going to use in this course, and you'll see it here and there. That nitrogen in there, makes it useful for all sorts of things, like fertilizers and explosives and plastics and dyes. And it makes it a major part of the nitrogen cycle, which provides nitrogen for all of our biological molecules that also include nitrogen. So things like proteins and DNA, etc. So let's have a look at a few of these possibilities here. That part there is the ammonium. This is chlorine. So we'd call this ammonium chloride. And the next one is ammonium chlorate. So this would be NH4, which has the +1 charge, and chlorate, ClO3, which has the negative charge. Since they're both 1 and 1, we only need 1 of each. This one here has 2 ammoniums for every 1 carbonate, which is what you get when you do your crisscross. And so this is ammonium carbonate. And the last one here is ammonium phosphate. Ammonium, of course, is NH4 plus. Phosphate is PO4 3-, which means we're going to need 3 of these ammoniums to balance out that phosphate. So we'll put brackets around our ammonium, and we'll take 3 of them and attach that to a phosphate. There we go, our last ion. So our last stop is a little memory aid to try to help you to keep all these ions straight. We have nice students pass chemistry class. How awesome. And so that corresponds with the names for all of the polyatomic ions that we have learned about today. So first one is nitrate and sulfate and phosphate and carbonate and chlorate and hydroxide and ammonium. And then you do the same thing down here just with the formulas. So NSPCCl. So for the first 5, these are the ones all with oxygen. You're going to put an oxygen with each one of them. O. And then you can follow this basic pattern. 3, 4, 4, 3, 3. 3, 4, 4, 3, 3. And then the charges go up and down. So -1, -2, -3, -2, back to -1. So that's good for the first 5 there. It sort of keeps them straight. And if you write it out a few times, do the 3, 4, 4, 3, 3, 1, 2, 3, 2, 1. That's a way to help you get those in your head when you're first learning. The last 2 they don't really fit with the pattern. So you got hydroxide with -1 and ammonium with the +1. All right, hopefully that helps you on your journey of learning about polyatomic ions. We'll see you soon.